All right, so we're started for this workshop. So this one is follow the gap. So let me put it in full screen. All right. So the last one, which was a wall following, right? So to be able to navigate autonomously, one of the technique would just be you have you find a wall or like an extremity, and then you just follow along with that. Like you don't need to know the map of of where you're trying to go. You should be able to just be able to navigate autonomously with that technique only. However, it's not optimal for racing or if you have obstacles, a lot of obstacles, right? Because if the wall is straight and then there's like a rock in front of you, or something in front of you, you wouldn't really be able to avoid it, or at least avoid it on time if you really need to race. So now this technique, which is follow the gap, it's called a reactive uh, obstacle avoidance technique because the reason it's called reactive is because uh, it doesn't need to take into account any map or anything at all. The decision is based on what's happening at this particular moment in time, and so that allows the vehicle to avoid obstacles that are like whether it's static obstacles or dynamic obstacles. So static obstacles like obstacles that are not moving, and then dynamic obstacles are like obstacles that are moving, such as other cars and stuff like that, right? So this is what we'll kind of like go over, and I guess make sure you I guess sign in just so we can see how many people attend those workshops overall. And if you haven't joined the Discord already, feel free to join too as well. All right, so well, I guess this next one is it's kind of like just like last time. If you're interested in helping out with with committees that we have, basically the committees are just a group of volunteers who want to help out with a specific thing, with the competitions, workshops, and running the this initiative overall. So currently we have three open committees, which is a PR and marketing committee, workshop committee, and sponsorship and industry liaison committee. So the sponsorship one, it's just to try to like get us money and all that. So feel free to join any of them or multiple of them if you are interested as well. And okay, so these last forms. So as you know, our competition will be April 3rd. It's a Friday, so it will be in between. We have the room reserved from 3 to 10, so the competition will take place somewhere, sometimes in between that time frame. So the first QR code, this is for if you have a full team and you just want to register that team. So this is like the official registration team. And then the second form, it's if you want to participate in the competition. However, you don't have a team, so we can kind of like just put you in a team. So feel free to scan the appropriate one, and we can move forward. And also, by the way, even you guys can compete. Like even if you're on e-board, you can kind of like join the team, like one of the research team, or create your own as well. So it's up to you guys, just in case you didn't know. So there is that. Next thing is, I guess, like let's start with like explaining what exactly is object avoidance with follow the gap, right? So if you have a map like this, right? If you were just using the wall following method that we were doing last workshop, right? Even if you pick like a singular wall to follow, right? You could just, let's say you follow this wall right here, um, right? If you're following this wall right here, once you get here, you'll kind of like hit this obstacle right there, or you'll not be able to react in time to make like that sharp of a turn. So that technique is not like like the best one to to navigate a map that has obstacles, right? But if you do the follow the gap, so the follow the gap is basically trying to find the biggest gap from what the vehicle is seeing, and then for the vehicle to like steer toward the middle, or like in between those gaps, right? So if the vehicle is here, it will see like, oh, this is the biggest gap, and try to like go there, and continuously it will just avoid obstacles just because of the way the algorithm is created overall. So this is kind of like what it would look like on like in the simulation, if you have your vehicle and you're using this map and you implement like a decent follow the gap technique, so you can do that. uh, and this would be like what it would look like if you implement that technique on the physical vehicle, right? And then it's kind of like going along and avoiding those obstacles. So how does it actually works, right? So you have your vehicle, and we're using lidar for the vehicle, right? And the lidar is just kind of like what the lidar gives you as the sensor, it just outputs like an array of numbers, and those numbers are pretty much how far how far away you have something at that particular angle. You have like the angle will depend on the range of the lidar, right? It would probably start at, like, let's say an example is like it start from 0 to like 180 degrees. So the first one would be, okay, so at 0 degree, so which would be like and if we're using this position and this is 0, at 0 degree you have like something that's like zero point 0.5 meters away from you, and then at it's at 10 degrees you have like something that's 5.1 meters away, and then you continue. And those numbers are pretty much describing what the lidar uh, is seeing, and you would use those numbers to try to find uh, a gap and try to like steer the vehicle in between those gap, right? So if and of course when you see like infinity, it means that the lidar has a range, right? Ours has a 10 meters range. So if an obstacle, or like if something is like above that 10 meters, we will say it's infinity, because the light never returned, so it couldn't really calculate how how far away. So keep that in mind when you see like ranges like that. And something to keep in mind is, like, let's say if you know you see a bunch of arrays and with a bunch of like obstacles, right? You might think, okay, so the best thing to do would be to find the one that's the furthest away, and then just kind of like make the vehicle go straight there. However, one array of lidar might be able to like go through that obstacle, but the vehicle has a physical dimension, so the width of the vehicle will not allow it to go through there and avoid the ones that like those two that are like 2 meters away. So that's something to keep in mind. And when we're kind of like designing our algorithm for it. So because of that, the goal is to find the gap, like a series of like a continuous points that are like far away. So instead of like focusing on the points that's the furthest, you're just trying to find the largest point that is like like the largest point, the largest gap pretty much, that's like a certain distance away. So that's kind of like that's one. You have a sure there's an obstacle that's like a zero point 0.5 meters, and then however in between zero point 0.5 meters and 3 meters there's like a, obstacles there, but they're like way further. So you want to, so that would be like there's a gap in between this and this. So that's one gap, and then there's also this gap, the second gap. So you have two gaps right there. So the goal would be, a let's try to like go toward the biggest gap. So which would be this one, because there's like more consecutive points that meets the threshold. In our case, for this one, the threshold was like three. So there's that. And the steps is you find the gaps, you calculate the width of each gap, and you pick the widest gap, and you kind of like move there. And something to keep in mind, let's say if you were to, if this is what you see, what the vehicle see, and if the logical way for the vehicle to navigate, it would be for the vehicle to like go through here, right? I mean, it's pretty obvious what it needs to do. And so you could be like, okay, so the vehicle just go to that point right here, to that point right here. However, there's like something to keep in mind, right? So the vehicle itself, it's not something that can just, just it has to obey the law of physics, and the way it moves is through wheels. Like you can't just be like, hey vehicle, just go straight there. If you just go straight there, you will, the side of the vehicle will hit here. Even though sure you found the widest gap, and you are steering the vehicle toward the middle of that wide gap, but if you don't take into account the physics of the vehicle, then you will still hit obstacles in your algorithm. So what you would need to do is, kind of like move a little bit on the side, and and go toward the middle. So the reason we have to do that, let's not go too deep into that one, is because there's like two types of robot, right? There's like holonomic robot and non-holonomic robot. So a robot that cannot move however it wants, it's like a it's like a non-holonomic robot, right? So if you have a vehicle, if those are cars, let's say you are in car, you parked, you know, you parked in this parking spot, and then you're in car number two, and you want to go to that spot. That spot is open, and you want to go there, right? You can't just make the car go sideways, right? You'd have to make the car go back, and then steer over there so it can get there. So that's something that's just a background knowledge to keep in mind when it comes to like uh, steering, like like a vehicle to do something, right? We don't have four wheel steers like this car. So so even though we have that technique to just find the widest gap, we still need to do a few things, a few tweaks, so that our algorithm can work. And one of those tweaks would be to just kind of like create like a bubble around the vehicle itself, and around the obstacles themselves, right? So what you would need to do is, okay, so this is the nearest obstacles, right? Instead of like trying to like find just finding the largest gap and steer there, you take into account the nearest obstacles. You put like a bubble radius in front of it, right? And then you adjust your vehicle, or you kind of like in a way program it so that it try to like avoid the nearest obstacle when you take into account the bubble. So, because it's trying to like avoid this, and it will try to like avoid all of this because there's like a bubble all around here. And this is the area that has, that does not have bubbles that would kind of like hit the vehicle. So the vehicle will, naturally would kind of like go this way. So that is, that would be like the furthest point, and like kind of like what you would need to do to improve your algorithm, right? So this is also like an example of the vehicle following the gap, using the follow the gap method. And another thing is that if you're just using that method, when you get to a point where it's just like a straight corridor, or like a straight path, so you will see that the vehicle will wobble a little bit, right? And I'll explain why it would do that. Like right here, it's a straight path, but it's still like wobbling, right? The reason it's doing that is because let me see. So there's like a few reasons why, right? So something to keep in mind before we get to that part is when you are racing, right? If your vehicle is like racing, right? So if you're just doing just straight follow the gap, and you're not trying to like improve that technique, if it gets to a curve like this, the vehicle would just follow along that curve, right? However, if you are in a race, you want to, you know, you could go straight, and if you go straight, that would actually save you time, and your and your lap time would be better. So instead of just trying to like just follow the biggest gap, you can also take into account in all of these big gaps, right? What is the furthest point where the vehicle can safely go through? So you make it kind of like do that, and of course, you will need to also take into account using the safety bubble method that I mentioned before. Need to take that into account to make sure that the side of the vehicle does not hit um, the wall. So because of that, like the vehicle would need to like steer like over there, because that's the furthest point it can go safely through there. And once it's like near there, it can just kind of like do another turn, whatever, because it's kind of like a reactive method. So this is uh, an example of someone using follow the gap at one of the
Three,
competition.
two, one.
And as you can see, it's pretty advanced technique. As in like it works fine, like
So the second round started running right up to here from one of the team members itself on what is the secret sauce.
A simple one-dimensional obstacle loading followed by critical parts that can drive it as fast as you can.
all right. So this is an example of a follow the gap, and not just straight follow the gap. They did some improvement with the disparity extender, which is the name of the technique that I mentioned before. It's sure there's a big gap, but where's the furthest point we can go toward that big gap hitting up without hitting anything else. So that's why it's able to like kind of like move a little bit smooth like this, and this would just be what the lidar is actually seeing in the race itself. So that's just something to keep in mind, I guess. So, and with that approach as well, we follow the gap method. You also don't just want to make the vehicle go at a constant speed, right? So you might want to change your speed based on how far the vehicle can actually go straight without hitting any obstacle. So, or like how deep is the furthest point in a gap. So if it's like you can use like a velocity profile like this, where the lowest threshold is just like a constant speed, and after that the speed changes based on how deep the the deepest point of the gap is. So, and I guess this is just like an example of the vehicle actually avoiding obstacles using follow the gap, which is pretty impressive. That's a kind of like a really good. They implemented it really well, I would say. So yeah. All right. So another thing as well to keep in mind is um you also do want to make sure that when your vehicle is turning, it doesn't hit a corner. So if you have a situation like this where the lidar is in front of the vehicle, which is usually how it is in most vehicle, right? When it's there, the lidar will see, oh, free space right here. So we need to steer right there. And if it was right here and then it makes like a sharp turn, the back of the vehicle will hit this corner right here. So what you would need to do is actually, yeah, what you would need to do is you need to take into account the what the back of the lidar is seeing, right? So what you can do is just sure the front of the lidar see this big obstacle, right? But what you can do is if the back of the lidar is still hitting some obstacle to the side, what you can do is instead of making a turn, just make the vehicle go straight. So that will make it avoid hitting the corner or like sharp corners like this. And follow the gap method is a pretty great way to navigate autonomously, and it's a good start if you're getting into racing as well with reactive method. However, it doesn't always work in all situations. So this would be an example of where follow the gap would just straight up fail, right? So basically, if the vehicle is right here, and if you look at that map right there, you could be like, okay, so this is the way to go, right? But follow the gap, just trying to like follow the best, the furthest point, the biggest gap. Once it's there, this will not be the furthest point it can follow, and not the biggest gap. The biggest gap to the vehicle will be like right here, right? So it will just steer toward that corner. And when that happens, there's nothing you can do. It can even like make a U-turn, trying to like trying to like go there, and then oh, the biggest gap is like right here, and then it goes back. So obviously, and in some situation, if you implement it well, or if it's not that much of an extreme case, once it's like go there, you might see that this is the biggest gap, but it doesn't always happen. And you will see like in I think this is an example of it. Running into that issue, like trying to like find the biggest gap, follow, and then it will end up kind of like doing a U-turn. So this guy will put himself like over here, and by trying to like avoid that obstacle, it just sort of like like a U-turn. So in this specific situation, the vehicle ended up like going back, but that was just because of that specific map or like that they used. So it just so happened that going back was still like the biggest gap after it was like over there. So that's something to keep in mind. And now to tackle the the jiggle problem, like it was kind of like wobbly. So what usually happens is that as the vehicle is going straight, right, it will see that, oh, if the vehicle's right here, it'll see that, oh, this is the furthest point, the and the biggest gap. So let's try to like steer toward going this way. And when it does that, let's say it's right here, now it will see that this is the biggest space and the deepest point to go. And then it goes right here, and then it just kind of like keep on oscillating. So that's why in that video before, you saw that the vehicle was oscillating. So
Right.
let's see if I can find the video real quick. Uh, right, even though it's like a straight space, it was still wobbly. So it was because of that. And overall, those are kind of like the main things to keep in mind when you are implementing a follow the gap technique, and how you should actually do it. And let me see. Yeah, overall, follow the gap is
Right.
it can be pretty So that's pretty much it for the presentation. Now, like like for the hands-on practice, feel free to go on our workshop website, and yeah, so use the live canvas uh link for this workshop, and go on preview only, and this is the guide to implement the follow the gap technique, and you will use the simulation to like test it. So as you guys are kind of like going through this, if you have questions, comments, or concern, let me know, and I'll try to like answer them to the best of my ability. But yeah, anyone got questions right now? Comments? Yeah.
Is there a fix for the corner issue? You know how the U-turn?
The U-turn issue.
Is there a fix for that, or
Not really. Just because like it just like to fix it, it will literally kind of like defies the the method, that it's like the fix. What the car is supposed to do is to not follow the gap. you know, like the biggest gap. So there's no real fix unless you like hard code it. So there's that. But for the competition, we're not gonna have like cases like this in the track. So that's not like something I would need to worry about. It's just something to keep in mind. But the international competitions though, they do have like things like that. We the last one we went to had one had something like that. So yeah.
in the actual competition, will people be stepping in and will they be doing like what they did in the video, or it's just let the cars race?
Yeah, so people will not beat the obstacles, right? So the only involvement people will do, it's members of the team that when once they're like when the car is like driving, if the car like hit one of the side walls and kind of like misplace the track, then your team is responsible for fixing, like push it back to fix the track back. And when your car crashes, your team members are responsible to um, put your car back to the last good position it was at without hindering the other vehicles. So yeah.
Is it like a certain number of cars like on the track at a time?
We'll probably just do. We'll start with two and see how we can kind of like move forward with it. So yeah, it also depends on like how well the vehicle can avoid each other as they're like moving fast. So you know. Is everyone here in a team already? Like, okay, who is competing? Like, who wants to compete? Raise your hand real quick if you want to compete, or if you are competing. Okay, okay. So who is not in a team and is competing? Okay, okay. Yeah, just make sure you kind of like use that form that I showed in the beginning. Yeah, and then just kind of like so I can have a good count.
What team are you in? Or are you guys with someone? Team? So only cars.
I mean, yo,
Yeah.
yeah. Um, I can't be on any team, but you guys would probably be joining or like make it, yeah, like be with because Andrew will be in on team. Um, you guys probably be in his team, or there's also Mary Jane, but I might split you guys just because um I feel like it wouldn't be balanced, because you know I feel like we need a good like a balance. Yeah, yeah, yeah.
Yeah.
Yeah. Let's see. Adrian, what team are you in again? What team are you in again?
I think it's called like Grade Machine.
Okay, okay. It's one of Shep's team, or is it IEEE?
IEEE.
IEEE. Okay, okay, okay.
Yeah.
When did you join them? Or did you was it like?
I got a deal with him like from before. He just told me to join. I was like, all right, bet.
Oh, all right, bet.
Yeah, great. Oh, great machine. I never heard of it.
You can go whatever you want.
So right now we're going to the hands-on material, and for the presentation, as always, I will upload them later. Probably not later today, but tomorrow. I'll upload them and along with the recording as well, and with this manual too. And for technique wise, this is the furthest we'll get technique wise for this semester at least. So with this, you should be able to race pretty neatly and compete with other teams. So um, moving forward, we'll be focusing more on actually building and testing the vehicle. So just keep that in mind.
just copy and paste this into like here or here.
So, which part?
This. So like
Oh, to actually build and test it.
yeah.
So if you are building the workspace, it's done through the terminal. Like yeah, this is kind of like the terminal.
Yeah. I just off it or
I mean, if you want, you can do no, not all of it, because you need two terminals. So this is a, you know, one terminal will be running the the simulation, and the other one will be running the actual node.
like would I make that another one?
Yeah, you can make another one here or use the other terminal if you want, but I mean, you need to try running the simulation first and see if it works.
Yeah. I think that's done. Oh, I don't think it's saved.
Which one? Oh,
This. Yeah.
so usually what you need to do is
Still falling. Yeah.
let's see. So you see how it's not launching the simulation?
Mhm.
That's because you also need to source where the simulation is at. Remember, you need to like a source install. Remember the folder the simulation is at. So if you,
Oh, I think I do.
yeah. So um, you need to like go through it. I mean, using the terminal and source it and then run. So that's why you can't really just copy and paste all of it. I mean, as like you just need to know where it's at, right?
Is this right?
The simulation, no. Let me see. Go back again. Let me see. I'll go back. I think it's like in sim workspace, so it's there. And let me go real quick. This was just to check it. Now, if you open the terminal, let's open another terminal real quick. So we have two. So in this terminal, let's say we go home, right? And you go in the city is to go to inside this folder. So this is the folder that has the simulation workspace.
And would I do this every time I want it?
To run the simulation, yeah. Unless you make it auto run, you need to add it to bash rc source. Everything is good, right? Did you run into any issue? Or did it work or you didn't get? Okay. Oh yeah, that's fine. Yeah, no problem. All right, nice to meet you, bro. Install and then setup bash. All right, so ROS 2 run F110 Cambridge. Well, that's awkward.
Bro, no, I mean, that's just, I mean, I had no choice but to put that. So I wonder if I have to unfollow that to the bone. Like, if I can go off track, will I get, like, banned or something?
Mm,
Like, do they put that in the system
Okay, it seems like your simulation is not running.
Yeah, worked last time.
I was about to submit it. We'll do it this summer. Maybe? I need some team recording.
Mhm.
For the SolidWorks workshop,
Mhm.
is that gonna be recorded?
I'll try to record it. Oh well, I'm not the one doing it, but I'll ask the host to try to record it. That's the goal for it to be recorded,
Okay.
and
Yeah.
it's next Friday.
Yeah, I got into SolidWorks certification
Oh,
thing, and the workshops are from 5 to 6:30.
oh, on Fridays as
Yeah.
well. Oh, okay, okay. I mean, yeah, it will be recorded. When do you start your certification thing? Next
Today.
today?
That's why I'm late.
I was trying to say you should probably go. Okay, it ended already. Okay, okay, okay. But yeah, so if you if you go through them, I mean, you will be an expert soon. But this one is pretty. It's very basic, so you shouldn't have a problem with just kind of like going through the recording and follow through. Yeah, and this is the last. Well, I mean, not the last workshop overall, but the last like advanced one. The other ones will just be kind of like actually trying like testing stuff, right? By the way, are you in a team already?
No, I filled out the team form.
Oh, did you when did you fill it out?
Um, Maybe like 2 o'clock today.
Oh, okay, 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 okay. So you didn't come to the meeting today? Because I mean, I guess you didn't fill it out yet.
No, I
Okay.
got class today.
Oh, at 2?
Yeah.
Okay, okay, that's fine. Um, you want to be put in a team, right? That's what you're saying, right? Okay. So if you fill it out, I'll reach out and you know decide on like put people in teams after we get I get like after this weekend probably.
Okay.
So yeah,
Thanks.
yeah, no problem.
I don't know. I see that.
Okay, so what do you guys do today for the 2 o'clock?
Oh, we so most I guess the teams that are kind of like participating, they came and we were discussing like parts and stuff like that, like bill of material and like what can they do with things like that.
So most likely would be in that guy's team, right? What's his name?
Yeah, him or MJ's team.
There's 2 teams for us.
Uh, Technically it's three, but we'll start with two. We'll fill out the first two first. It will low key depend on like how
Us
many
down.
people needs I see. It would depend on how many people needs a team as well.
No.
Yeah,
Would they be placed in our teams, our AI user teams?
most likely because that's the one to we can easily integrate people in because we don't have that many like people participating anyway from our group. And I used the wrong command. I was like, what?
So you just like memorize all these commands. That's so too weird. Like you can just type it out.
Which commands are you referring to? Like regular?
Yeah, just like those regular commands you're typing like right now and stuff.
I mean that. I mean, I really don't know a lot of them because um, I mean, the basic one I know a little bit, I guess. But besides that, it's like I have to look. Oh, this. Let's see. You said it worked before,
Yeah, it worked. I got in the simulation before. Like it pulled up like a new screen, and then I was like,
and was it running?
I didn't get. Oh yeah, like pulled up like that.
But
I,
it
I
was
didn't.
no.
I didn't get it to work.
Okay, so okay, I guess it wasn't like done. You done. Let's see. Okay.
Yeah, I got like that, and then
So you never saw the tracks.
no.
Cool. All right. So what happens that I don't think you didn't adjust the map parameter. So like in the workshop about like installing the simulation, so there's like a portion like telling you to like to change this to your actual directory name, and then once you do that, you rebuild it. If it works, that was the issue. If it doesn't work, that was just one of the issues. Source install setup bash. Dun, 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 dun. Okay, so now the map is loading. Still not good yet. Okay. So now let's see what the issue is. You're a sophomore, right, or
Yeah,
freshman?
freshman.
Freshman. Cool. EE, right?
Yep.
Did you get a chance to work on any project this year, like besides this one?
I was thinking in the summer, but I'm still deciding my what project. Either, I mean,
Have you tried like building any PCB before?
I went to like an IEEE workshop, but that was
Those are.
we followed like a tutorial thing, which they had like a PowerPoint for, but like besides that, like learning on your own, that seemed really
What did you build in that
like, yeah, it was
workshop?
like a PCB.
Like which what did the PCB kind of like do? That's kind of
Oh,
like
I don't know about that. I don't know. I think it might be still saved on the Kai, something.
oh, keycad.
Yeah, keycat. But there was so much stuff I didn't know. Like even the parts, like the parts that you put on the PCB and stuff. Like, I didn't know what they do. They like
Okay.
forgot the names already. But, I didn't know. Oh, I gotta learn that sooner. Not sooner, but
Yeah.
sooner better. You think I should like learn? That'd be a good project too,
I mean,
or is that like a later?
no, the sooner the better. As in like PCB design is like one one of the big branch of EE. So it's like you know.
I was thinking like before that, I was like thinking that I should like follow a tutorial on like um building like what's it called, a traffic light or a remote control like RC thing, and then just go with that for a summer as a freshman summer project.
I mean, if you can, yeah, go for it.
I do both. Like I do that and a PCB. I learn PCB. Oh,
Mm,
what are you trying to do now?
I mean, it's not working yet.
You think it's probably some other thing I didn't do yet.
You might need to like start over with the simulation installation. All right, I think you might need to like start over the simulation installation. So delete those two folder, this one and excuse me, and this one, and then yeah, go on that.
and just start over from
Yeah, the
7 or 15.
yeah.
Um, not Ross.
You don't need to delete that one. This one.
Delete it in the trash, right?
Are y'all doing good on it? Everything's good. Good.
Yeah, I need some help.
Mm-hmm.
I missed the GBM last week because I didn't know it was on Wednesday and I had a lab.
Yeah,
So
that's fine.
low key, I'm still stuck on. I still need to finish up the second one, or the stuff in the second one.
Oh, the simulation was never working.
Yeah, I never really got it working. I got it to this point, and then whenever it tells me like to adjust anything or configure it,
Mm-hmm.
it stays the same no matter what.
Okay. Let's see. Uh, all right. So if the map is not loading, that's because the path of the map is most likely wrong. So let's see where we at. All right. So if we're going, oh, do you have VS Code installed now?
Do I have what?
VS Code
Not
on this? Okay.
there.
Yeah.
Actually, I think I do. I think
Let's
you
see.
helped me put it out. You helped me install it.
Okay. This is a yes, such as. Alright. So source.
If you want, you can maximize it.
Yeah. Okay, so you would need to change that to whatever yours is, right? So on the way to find out what is your current
Oh, I gotta put the right directory.
yeah.
Okay.
So yours is home.ai, I guess. It's just AI. Simply just change this to AI. Alright. And this would should work, I guess. But now let's try to like let's try to rebuild it. So alright, see y'all around. Now if you lunch that's hard. Alright. Let's see what that could be. Did you modify anything from there by any chance? No.
For the
For the simulation,
yes.
what did you modify?
I think I changed like the number of opponents and like I think that was it.
Uh, did you change it from 1 to 3 or something?
Yeah. I was just like messing around, see if I can get it to change something.
I think the max you can do is 2 anyway. So
Okay.
if this doesn't work, we might have a bigger issue. That is crazy. Um, everything is showing. Oh wait, hold on. That is odd. Because the laser in the car is showing, and seems like the map is there too. Uh,
I could have changed something else, but I don't
yeah,
remember.
like you probably did. Like you might have changed something else.
You mind if I look at it actually? Because I might be able to like determine.
Let's see real quick. Okay, let's just close it and close without saving. Let me look at the so okay, so you have maps, Levine. I'm assuming you would have hmm. This is only this was modified okay, I see. All right. Yeah, I'm good now. That works. You might have changed something else, like you said, just because it loads differently. Like usually the duration is straight, but that really doesn't matter in this case.
Okay.
But but yeah, so the simulation is now working. So from here you should be able to do the following labs. You can either do the last one with while following, or you can even do this lab if you want to, because this lab doesn't depend on the last one. It's just two different technique basically.
Thank you.
Yeah. How are you doing?
I'm also having some issues with the last lab.
Oh, the last lab itself.
Yeah. Um. So my map was working like a second ago, but I think
Okay.
after I changed the fixed frame, it got warning.
Okay. So are you trying to like do? Are you doing like your own launch file for the last lab or something?
I'm using the ROS command here.
Let me
So
see.
I have this launch file.
Yeah. So to be fair, you really don't need to use those launch file. But was it working before that?
Uh, yeah, it was working.
As in, like, was the vehicle driving before that? Fine.
Yeah, I was driving. It kept hitting the wall, but it was like driving. The map showed up.
Okay. So what you need to do is like go back to that part and um fix the configuration so that the vehicle can drive on its own. Because you this those extra steps to like configure a launch file to make everything start together. It's a bit more like I didn't even test it yet, so I can't tell you if it's an issue on my part or if it's like you probably did you might have done something wrong. But if it works and your algorithm works fine and it can and use the second map, not the first map. Let me see which map you have right now.
I have like the long, like racetrack map.
Oh, the long. Let me see. Does it show
Um,
the Spiegel or whatever it's called, right? Or is it the Levine?
I think it's the Levine. Can you? Is it in the package?
So it should be on in the simulation. Go on simulation real quick. The simulation folder. You can just use the uh, sim workspace source. Yes. And then do config simyaml. Yeah. Scroll down real quick. Yeah, okay. Yeah, using the right map. So yeah, make it work on that one on like without doing the launch file and all that. And if it works there, where you manually launch the simulation yourself and then you manually launch your own node. If it works there, and you can do a full lap without it crashing, then you can try to like practice on making a launch file that makes both of them run. But you probably have to like try that on your own and try like fix things that don't work. So yeah, it's just that.
I think right now I just launched just the simulator and the map.
So you probably have another simulator running, might maybe.
Maybe. Yeah. Is there like a kill all command?
Not that I know of.
I
uh,
think in our like.
go on your all of the. Do you have any other terminals?
Oh yeah.
Yes, I mean, is any of them running currently?
No. All of them are off. I think.
You can try to run the simulator alone. And normally these don't show. Did you modify your simulator to like for this to show?
Yeah.
Okay. Uh,
I just try restarting.
close this terminal. Go on VS Code and Okay. Do you have multiple instances of VS Code open, or is it just one?
No, just one.
Does it have a terminal section that's open by any chance? No.
I don't think so.
Okay. All right. Go. Open a terminal and try to relaunch it. The simulation. Yeah, that just I don't. You might have.
Maybe just try and restart it.
No, you probably change something in the configuration, or of his configuration. Was it working today or?
Yeah, it was like working literally like a second ago.
And what did you change? Do you remember?
I think I tried flipping the error thing because I think that was a suggestion, and then I also added the TF display. I think that was it.
Okay. Did you make the change to the simulation workspace, or was it in your workspace that you have your node in?
Um,
Do you remember? No.
I made the change in. I think the TF display was like on RViz, and then the other change was on the Python code.
Okay, so if you did it on RViz while the simulation was running, so you that was you, and I'm assuming you saved it, so you modified the configuration file for RViz and the simulation. So if it doesn't work now, I mean, you could try to like fix it, try to like figure out what it is, but you could simply just reinstall it, and then it would. Because right now I can't really tell what. Let me see. Oh, go on fix frame real quick, and click on that and do map. Press enter. And I think it should be on map, not if I'm not mistaken.
I think here it says set to baseline.
So that one for like when you open another RViz, right? So you would have like two open in a way. One would be just the simulation, and the other would be like an extra debugging tool where you would be able to just see the lidar and actually see the vehicle based on like
Yeah, maybe that's why.
yeah open the map thing, the map thing right here. Did you change any of these by any chance?
Yeah, I added the TF display, but I think you're supposed to do it in.
Yeah. Um.
I think I also changed.
Did you change like any of those right here?
I don't think so.
Okay. Go and update up, keep blast reliable volatile durability. Change transient local to volatile. Mm. Okay, what I would say is just the easiest way to just try like either like reinstall the simulation or try to get your old simulate sim.yaml, or not the sim.yaml, your RViz2 configuration file back. So both should be pretty straightforward to do. What you can do instead of like trying to like to install this simulation from scratch, you could
I think
it
I
works.
restarted it again,
Oh,
and it works now.
there we go. Hey, fix itself. But yeah, doing good.
So far.
All right. So I'll probably end this workshop. I guess like right now.
Yeah, I'm about to leave.
Yeah. So So yeah, let me turn this
Sorry,
off.
is what does it mean? What does this mean?